All right, we're going to check the solutions to our independent practice. 3 minus 5x is greater than 38. We're going to solve this just like a two-step equation. First thing you should do is subtract 3 from each side to get rid of that constant 3. That's going to leave us with negative 5 times x is greater than 35. Next step will be to divide by negative 5. Now careful, when you divide by a negative, we learned a new rule today. When you divide by a negative, you're going to flip that inequality symbol from a greater than to a less than. So be really careful. Since we divided by this negative 5, that's why we're doing that. These will cancel, leaves us with x is now less than 35 divided by negative 5. So use Mr. Multiplivision. 35 is positive, negative 5 is negative, so we're going to get negative 7. We're going to check that. So we're going to pick a number that is less than negative 7. So if you look at the number line, I'm going to pick negative 8. And I'm going to plug it into the original inequality. 3 minus 5 times negative 8, because it's less than negative 7, should be greater than 38. If it is, we know we're right. So let's solve it out. 5 times negative 8 is negative 40. 3 minus negative 40, you're going to do keep, switch opposite, and it really becomes 3 plus 40. 43. 43 is greater than 38, so we know we're right. If we interpret our solution, x can be any number less than negative 7. All right, we're going to keep motoring through these, try to keep them to 2 minutes or less for each question. So number 2 is half of y plus 2 needs to be less than or equal to 17. Let's go ahead and solve. First thing we're going to do is take away 2 from both sides. Half of y is going to be less than or equal to 15. Now dividing by half is the same as multiplying by the reciprocal. So we're going to multiply by 2 over 1. Or in other words, 2 on both sides. 1/2 times 2 will cancel. We get y. 15 times 2 gives us 30. So y needs to be less than or equal to 30. That's going to be our interpretation. Y can be any number less than or equal to 30. So let's check that. Let's pick a number less than 30, plug it in and see if it works. Let's pick 10. So if we do half of 10 plus 2, is that less than or equal to 17? Half of 10 is 5, plus 2 is 7. Is 7 less than or equal to 17? Yes, it is. So this is a correct solution. All right, number 3 is that first story problem. Directly underneath number 2, it says if you have $35 in the bank and save $2 per week, when will you have at least $125 in the bank? Here's what you should have done. You're going to save $2 per week, plus you already have 35. We want to know when will you have at least, which means greater than or equal to 125. So there's our inequality. Now we're going to find our answer. Subtract 35 from both sides. That's going to leave us with 2 times w is greater than or equal to 90. We're going to divide by 2. And we will get w is greater than or equal to 45. If we interpret that, it's going to mean that you'll have $125 on the 45th week or any time past that. Okay, last one. Final story problem there about Charlie. Charlie is 2 years older than 3 times his brother Bill's age. If the sum of their ages is no more than 30, what is the oldest that Bill can possibly be? So we have Charlie and we have Bill. We don't know Bill's age, so we're going to represent it with X. Bill is X years old. We do know that Charlie is 3 times that old, so that's going to be 3x. And Charlie is not just 3 times that old, he's 3 times that old plus 2 more years. So that expression represents Charlie. If we add those two ages together, 3x plus 2 plus x, the story problem says that it is no more than 30, which means it's less than or equal to 30. Here we can combine like terms, 3x and 1x. We can combine that into 4x plus 2 is less than or equal to 30, and now we have an inequality that we can solve. Take away 2 from both sides. You're going to get 4x is less than or equal to 28. Then we're going to divide by 4. And we're going to get x is less than or equal to 7, which means that Bill could be any age that is 7 or lower. And since the question asked us what is the oldest that Bill can possibly be, the oldest that he could possibly be is 7. He could be any age less than that, but the biggest age he can be is 7 years old.